Okay, in this lecture, we're going to look at the definition of science, and this will be a two-part lecture, so we'll start with part one. Here's the motivation. Suppose you heard an acquaintance describe a new way to avoid getting infected by COVID-19. Here's the solution. If you apply vapor rub under your nose, you can't get infected by COVID-19 because the vapor rub fumes repel the virus particles. So guess what? You don't need to wear a mask anymore. You probably don't need to get the vaccine. You can go about your business. You dismiss the idea as ridiculous. But soon after that, you see numerous celebrities touting the vapor rub prevention strategy for avoiding COVID-19 infection. Taylor Swift, Whoopi Goldberg, Dr. Phil, even Kermit the Frog. The celebrities claim that their belief that rubbing vapor rub under their nose protects against COVID-19 is scientific because a doctor endorses the strategy. But public health officials and epidemiologists and other medical professionals claim that the view is not scientific and that rubbing vapor rub under your nose offers no protection whatsoever. Who's right? So perhaps if we had a definition of science, we could see whether what your friend, the celebrities, and Dr. Oz claims is in fact science. If it does not satisfy the definition of science, it is not science. If it does satisfy the definition, it is science. So, we're going to see if we can actually, what is the definition of science? How can we define it? What's the motivation for it? So this is a two-part lecture. Part one, we'll look at the motivation for defining science. We're going to take a deeper dive into philosophical definitions. And then we're going to look at what we would want in a definition of science. The fancy Latin term is desiderata. In the next lecture, part two, we'll look at some sampled candidate definitions. And then finally revisit the question of whether or not we actually need to define science. So what's the motivation for defining science? Well, there's, many areas where science informs important decisions. Healthcare, expert testimony in courts, and various environmental policies, science education, and journalism. All right, so in healthcare, for example, should an insurer pay for homeopathic or alternative medicine techniques? Such as, rather than getting your gallbladder removed, you just treat it with essential oils and pineapple juice. Which is actual homeopathic alternative I've heard about. This is applicable to criminal justice in courtroom settings. For example, various forensic techniques like bite mark or handwriting analysis. Are they science or is it fake science? Various investigative techniques, such as certain methods of interviewing suspects and detecting lies. The environment. So, whether or not pesticides impact human health, safety of GMOs, certain types of farming practices. This is relevant in science education. What should be included in a tax-funded school science curriculum? Or what should be included in an accredited school's science curriculum? Even if a medical doctor gets trained at a private university, what are they learning before we give them that medical license? It also is applicable to education. Should intelligence tests and similar assessments be used to assess students and teachers? Are they scientific? Is there scientific evidence for it? Or is it not scientific evidence? Journalism. Should a journalist call someone who calls themselves a scientist, even if they are promoting what we consider to be pseudoscience? In fact, the public understanding of climate change was hampered by journalists giving, say, as a false balance to legitimate scientists and cranks. So journalists should actually maybe understand how representative a scientist is of the mainstream. Are they promoting a contrarian view that goes against expert consensus? For example, we don't, talk to astrophysicists and members of the Flat Earth Society in debates about the solar system anymore, because the Flat Earth Society members aren't representative of science. We'd say that's pseudoscience, fake science. Other motivations. So science is an honorific term. It's highly esteemed, okay? Most people agree that there is something special about science. When a claim is labeled as scientific, it implies that the claim is reliable. It's likely to be true. That's why advertisements frequently claim that a product is scientifically shown to be superior. For example, this toothpaste will give you whiter teeth. This Axe body spray is scientifically proven to make you more desirable to the ladies, as proven by Nathan Fielder. Here's an old ad. Scientific tests confirmed by independent consulting laboratory prove that Lucky Strike is the mildest of the 6 major brands of cigarettes tested. So these ads are appealing to the authority of science and scientists. Politicians claim to follow the science when they're making policy decisions. You've heard politicians say that a lot lately. In the 1980s, 90s, and early 2000s, there were debates all over the place about whether or not creation science is science. Both sides, the creationists and the non-creationists, agreed that there is a special category, science. What they disagreed was whether or not creationism counted as science. So they all agree that science is authoritative, it's reliable, it's honorific. There's something special about science. Likewise, many disciplines at the university are now claimed to be sciences, which is meant to imply that their methods are as reliable and fruitful as the methods that physicists and chemists use, like political science, there's economics, sociology, anthropology. In the wake of the 2008 financial meltdown, a number of opinion editorials argued that economics is not a science because economists, with few exceptions, failed to predict that economic crisis. Again, they agree that there is something special about science. The disagreement is whether or not economics is science. Likewise, many disciplines today claim to be sciences. Again, there's library science, administrative science, management science. So getting labeled as scientific is a status symbol for a discipline. It's a boost to the discipline's credentials. We find evidence for this in, for example, the financial decisions made by universities and in education. Usually the disciplines that are going to get their budget cut are in the humanities or the non-sciences. Dance, music, art, poetry, creative writing, English, philosophy. They are always having to fight for their existence, whereas the STEM fields generally don't. Think about STEM itself. Again, science is an honorific term, but think about what STEM means. It means science, technology, engineering, and medicine. The latter 3 areas are dependent on the first. You wouldn't have technology, engineering, or medicine without science. So maybe people subscribe to this argument then, and why they think that science is authoritative, it's special. And that's why they want, library science to be a science, economics to be a science. Well, the success of physics, chemistry, and biology, and other natural sciences is due to the application of a special method, what we call the scientific method. And if the social and human sciences apply this method, psychology, sociology, library science, management science, they will also be successful. This raises several questions, though. What's the scientific method? Is there just one scientific method? And does it apply to other fields? Well, here's the intuition. Science is special because it is objective. It is derived from facts, not opinions. You can debate whether Billie Eilish or Taylor Swift is the greatest singer of the 21st century. There is no debate over whether Einstein's or Galileo's theory of relativity is better. Einstein's is better. Engineers use Einstein's equations in theory, not Galileo's, when they're designing satellites. Okay? So how do we find the definition of science then? Well, can't you just look up the definition in the dictionary? Well, which dictionary? And which definition? Perhaps we can look to etymology, the meaning of the word itself, the kind of linguistic roots of the word. Well, science comes from the Latin word scientia, which means knowledge. Or take the word scire, which means to know. And science definitely involves knowledge. But here's the deal. Someone who knows every single detail about the history of lightsabers has knowledge, but we would not call that science. So knowledge isn't enough. Unfortunately, consulting a dictionary or the field of etymology will be of limited value if we're trying to find a good definition of science. Instead, we need a philosophical definition. And this requires us engaging in a type of activity known as conceptual analysis. So, we're going to need a good philosophical definition of science, not one that you find in a dictionary, or not one by looking at like etymology or linguistics. So what's a philosophical definition? Well, a good definition in general of science, a good definition of science, according to philosophers, is a definition that applies to all and only those claims and activities which are scientific, okay? So if a claim or activity is pseudoscientific, then it won't satisfy the definition of science. For example, phrenology, pseudoscientific type of theory of personality in the late 19th century. If a claim or activity is non-scientific, it also won't satisfy that definition of science. So history is not pseudoscience, it's just not science, it's history. So a good definition of science then applies to all claims and activities that are scientific, and a good definition of science applies to only claims and activities that are scientific. Well, before we look at a good definition, we should explore how you can misdefine words, okay? This will point us towards the correct way to define a word. So suppose your geometry professor defined a square as follows. X is a square if and only if x has 4 sides and x's 4 sides meet at right angles. Is this a good definition of a square? No. It's what we would say is it's a definition that we'd say is too broad. It includes entities that are not squares. But when a definition is too broad, the requirements in the definition are necessary but not sufficient. They are required but not enough. The definition is too inclusive. It lets a rectangle would count as a square even if the rectangle's sides aren't of equal length. Suppose instead your geometry professor defined a square as follows. X is a square if and only if x has 4 sides of equal length, x's 4 sides meet at right angles, and x's 4 sides are 5 inches long. Is this a good definition of a square? Again, the answer is no. This definition is what we would say is too narrow. It excludes entities that are squares. So, a square whose sides are 4 inches long or 6 inches long would not count as a square on this definition, even though it's definitely a square. So when a definition is too narrow, the requirements in the definition are sufficient but not necessary. They are enough but not required. The definition is too exclusive. Suppose instead your geometry professor defined a square as follows. X is a square if and only if x has 3 sides and the 3 sides meet at 60-degree angles. Again, this is a bad definition. It includes entities that are not squares and it excludes entities that are squares. How about this? X is a square if and only if x has 4 sides of equal length and the 4 sides meet at right angles. This is a good definition. It applies to all squares and it applies to only squares. So we need a definition of science that is similar, a definition that applies to all scientific claims and activities, but only scientific claims and activities. Here's why. A definition that applied to all, but not only scientific activities is inadequate, because it tells us what might be science, but it does not tell us what is science. On the other hand, a definition that applies to only science but not all science is also inadequate, because it does not tell us what is not scientific. There's a few other features of a good definition of science it must possess. The definition must be partly descriptive and normative. What does that mean? Well, this is what I mean by descriptive. A good definition of science must apply to what scientists actually do and claim into actual sciences. If it didn't apply to what chemists actually did, for example, it would be inadequate. If it entailed that physics is not a science, it would be inadequate. But also, a good definition of science must be partly normative. The definition should identify, big word, the epistemic or methodological features that mark off science from non-science. What's special about the knowledge claims and modes of inquiry of science? What are the superior evidential grounds for science? Yeah, there's something special we'd say about the scientific method. It leads to truth, or to reliable claims that you can count on, you can make decisions based on, okay? So the definition of science should identify what's special about science, why it's reliable, why it's authoritative, why it's objective, why we should take their claims seriously, basically. So here's not a good example. More scientists than non-scientists partake in Star Trek cosplay. This is about scientists. But it doesn't explain why the scientific methods themselves are more conducive to knowledge and why scientific claims are more likely to be true. So that's the end of this lecture. Turn now to part 2.